Okay, welcome to this video on second or group level analysis using SPM 12. So if we look at our overview of the whole fMRI univariate analysis pipeline again, you can see that we should have finished first or subject level analysis and have computed contrast. And then we can perform statistical inference on these contrast images to get this nice picture of the brain lighting up. So the result of first or subject level analysis is one contrast or con image for each subject and each contrast. So this will look like this. We have one con image for each subject like this that shows the difference between beta values for A minus B. And now we simply want to run a t-test in each voxel. So this is why this is also known as a mass univariate analysis. We perform a bunch of t-tests across the whole brain in each individual voxel. And so this is how you can imagine this. If we look at one particular voxel, we have all these different contrast values, one for each subject. And now we want to know, is the mean contrast value across subjects significantly larger than 0? So let's look at how to do this using SPM 12. So first things first, again, we will add the path of our SPM 12 folder by typing add path, adding this path, and then we can run SPM using SPM fMRI. Now, if we go to one subject's folder in the derivatives first level, and then, for example, go to sub 01, you can see that we have all of these beta images, which are the beta values for each regressor. And at the bottom somewhere we have these con images. So this is, for example, con 0001.nii is the con image of subject 1 for contrast 1. So to look at which this was, again, we can look at the spm.mat file of this subject by going to results and navigating to this folder, selecting the spm.mat. And now SPM will ask us to select a contrast. So for example here, contrast 001 is famous larger than unfamiliar faces. Contrast 2 is faces larger scrambled, and so on. So if we now want to run a second level group analysis across famous larger than unfamiliar, for example, what we want to do is we want to select this contrast image, con 001.nii, for each subject and run a t-test. So to do this, we click on Specify Second Level. Then our batch editor is going to open up. And now under Directory, we want to select the output directory of the second level analysis. So for this, I will create a new folder under the derivatives folder, which I will call second level. And then within this folder, I want to create a subfolder for the specific contrast. So we call this famous versus unfamiliar. This is where we want to store our results. So we select this under directory, select the dot, and then it's going to be selected here. So we can click done. Then as the design, yes, we want to perform a one sample t-test. Under scans, we then want to select the con 0001 images for each subject. So we would go to this derivatives first level folder where all the subjects are stored. And then if we go to sub 01, we can try to find this con 0001 image. Here it is. We can also try to filter for this by typing under filter con 0001. And now only this file is going to show up. And so we can immediately select this. If we go one level up, go to subject 2, select their con 0001 image. This is already going to be pre-selected because of the filter. Then subject 3 and so on. And you can see that this gets annoying pretty quickly, especially if we have a lot of subjects. So one trick here you can use is if we deselect all of this, you can click here on the left on rec, recursively select files with the current filter. And then it will select all the files in these subfolders that fit to our filter of con 0001. And you can see now we have exactly what we want. We have all the con 0001.NII images for our 16 subjects. And so we can simply click Done. Then here you could enter covariates if you have some. So for example, if your study includes age as a covariate. In this case, I don't. But one thing I like to change here is the explicit mask. So here I want to use a gray matter mask to restrict the statistical tests that we do to the gray matter. So I've already created a gray matter mask in the MNI space that I can use. So I will go to this folder here under directory and select this gray matter mask bin for binary as the explicit mask. The rest of the defaults can stay the same, and then we're already done with design specification. Then as the next step, we also want to estimate this model. So we click on SPM, Stats, Model Estimation. Click on Model Estimation. Then as the SPM mat, we can use a dependency. So right click, dependency, use the SPM mat file that we used in the previous step. The defaults otherwise can stay the same. Next, we want to set up contrast. So we click on SPM, Stats, Contrast Manager. Click on Contrast Manager. Again, as the SPM mat, we can use a dependency to select our previous SPM mat file. Then under Contrast Sessions, I will click on New T-Contrast. And now what I like to do here at the second level is to get both the positive and negative activations of each contrast. As con images are two-sided, we can compute both the activations for A larger than B and B larger than A based on the con images for A minus B. So say if we have famous minus unfamiliar, then we can compute both famous larger than unfamiliar and unfamiliar larger than famous. So under name here, I would put in famous larger than unfamiliar. And the weights vector will simply be 1. So we get the positive mean of our contrast images. Then I click on Contrast Sessions again, New T-Contrast. And now as the name, I will put in unfamiliar, larger, famous. So this is the reverse contrast. And then under weights vector, I put in -1. So we get the negative activations. Then finally, we go to SPM Stats Results Report to also show us the results. So if we click on this, select the SPM mat, again, we can click on dependency, select the SPM mat file from the previous step. Then under contrasts, click on New Contrast Query. And here under contrasts, we can use this trick again, which is already shown here in the help, that we can simply put in inf, and then it will show us the results for all of our contrasts. Under threshold type, so this is voxel level multiple comparisons correction. I will use none here. So to have a first look at the results, I will not correct for multiple comparisons. Then under threshold, so this is the voxel-wise p-value threshold, I will put in 0, 0, 1. And under extent, I will put in 10. So we exclude very small clusters, but again, just to look at the results, I will use these quite liberal values. We will later actually correct for multiple comparisons. I don't want to export any results, so I will also delete this PostScript export. And then we're already done. So now we can simply run this batch by clicking on the Run button. And here we go. So we have some results. So to select our first contrast of famous versus unfamiliar, we can go to Contrast, Change Contrast, and then select famous, larger, unfamiliar. And now this is still uncorrected, so 001 with just a 10 voxel threshold. If we want to do voxel-wise FWE correction, what you would do is go to Contrast, Significance Level Change, and then FWE 005. And now you can see nothing significant anymore. And so this is because voxel-wise FWE correction is very conservative. So to use cluster-wise FWE correction, we can go to contrast, significance level change, and then click on none for voxel-wise threshold. And here I will use 001 uncorrected as the voxel level threshold. And then as the extent threshold, I will use nothing at the moment. And now SPM will compute us the appropriate cluster level threshold. So for this here at the bottom, you can look at FWEC, and this is the cluster extent threshold. In this case, 159. So this means our cluster needs to be at least 159 voxels large to survive cluster level correction. So to do this, we can go to contrast, significance level change, none, 001. And now as the extent threshold, we want to use 159. And now we have properly corrected for multiple comparisons at the cluster level. So to look at this on a standard brain, we can click on Overlays, Sections, and then I will select an MNI brain from SPM. So go to Previous, go to our SPM folder, then Canonical, Single Subject T1. So this is the MNI brain for one single subject. And now you can also enable labels by clicking on right-click, Display Labels, Neuromorphometrics. And now we also have some brain regions. So if we go to these activations, you can see that the right middle temporal, superior temporal gyrus is one cluster. So this looks basically like superior temporal sulcus to me. And then you also have in both hemispheres here the fusiform gyrus. So this might indeed be the fusiform face area, which is activated for famous larger than unfamiliar faces. We can also look at the reverse contrast of unfamiliar versus famous. If we click on contrast, change contrast, and then unfamiliar, larger, famous. And now you can see nothing significant again, but this is for our previous settings. So we want to reset our threshold to 001 and no extent threshold. And now we have some activations. And now you can see again, there's a cluster level threshold of 148. So if we want to use this cluster level FWE correction again, we can go to contrast, significance level change, none, 001 and 148. And now we only have one cluster that survives this actually. So if we go to Overlays, Previous Sections, we can look at this again. Again, Display Labels, Neuromorphometrics to get some brain regions. And now if we navigate to this, we can see that only the right middle frontal gyrus is activated for unfamiliar versus famous faces. Now we can also save this batch to use it later again for other second level analysis. So we can click on File, Save Batch and Script. And then we give this a reasonable name, such as second level batch. And now we get again the script file, and we get a job file, which is the more interesting for us. This actually defines the MATLAB batch. And then go to batch, load batch here, and then select second level batch job. We can load this batch again, and now we can repeat this procedure for another contrast. Okay, now I want to show you one a little bit more complicated design at the second or group level, which is a two-sample t-test. And this you will often use when you want to compare two groups for one particular contrast. So say you have group X larger than Y for contrast A larger than B. For example, say you have two groups, old and young adults, and you want to compare their activity. So old larger than young adults for famous larger than unfamiliar faces. And so the design matrix of this would look like this. You would have the con images for con 0001. So this would be, for example, our famous versus unfamiliar contrast for subject 1 to 8. This is, for example, our group 1, the older adults. And then you have a second group, subjects 9 to 16 of our young adults, and this would be group 2. So to do this in SPM, we again want to click on Specify Second Level. Now, for directory, I want to again create a folder in our derivatives second level folder. I've already put the one sample t-test into another folder called one sample t-test. And now I create another folder called two sample t-tests. And here as a subfolder, I'm going to put in old versus young for famous versus unfamiliar. And we will select this path as the output. Then as the design, I want to change this from one sample t-test to two sample t-test. And now under group 1 scans, we want to select the con images of group 1, so of the old subjects. And here I will go to our first level folder again. And let's say, just for this example, subject 1 through 8 are the old subjects. So we want to select here the con images of sub 1 through 8. So this would be always con 0001. Again, we can put in con 0001. We can use our recursive selection again. But of course, it's going to select all the subjects. So we want to deselect subjects 9 through 16 by clicking on them again here in the selection. And now we only have subjects 1 through 8 con images. Click done. Then for group 2, let's say these are subjects 9 through 16. Again, we go to the first level folder, put in our filter con 0001 and click on recursive selection. Again, it's going to select them all. So now we deselect subjects 1 through 8. And now they are all in here, subjects 9 through 16. Click done. The rest of the defaults can stay the same here. Again, we want to use our explicit mask of the gray matter. So we click on specify here, go to our gray matter mask folder and select this. Then as the next step, we want to estimate this model again. So we click on SPM, stats, model estimation. Click on model estimation. As the SPM mat, we can use a dependency and select the SPM mat file from the previous step. Then we want to specify contrasts again. So we click on SPM, stats, contrast manager. Click on this. Again, we use a dependency to use the SPM mat file from the last step. Now under contrast sessions, again, click on new t-contrast. And now we have basically two types of contrasts. If we look at the design matrix again, so say group 1 here is the left column, the left regressor. Group 2 is the right regressor, the second regressor. And so here, if we use 1 minus 1, then we get larger activity for group 1 than group 2 for famous versus unfamiliar faces. And the contrast minus 1, 1 will give us larger activity for group 2 than group 1. So in this case, young versus old adults. So we want to specify these two contrasts. As name, we put in old, larger, young for famous, larger, unfamiliar. And the weights vector will be, as I said, 1 minus 1. And then we go to contrast sessions again, new t-contrast. And now we want to put in young, larger, old for famous, larger, unfamiliar. And here the weights vector will be minus 1, 1. That's it for contrast manager. And now finally we want to use results report again, SPM stats results report. So we get an output of the results. On this SPM mat, we click on dependency, select the SPM mat file from our last step, the contrast manager. And then we do the same thing as always. We go to contrast, new contrast query. Under contrast, we put in inf, so it outputs all of the out contrast, and the threshold type none, threshold 001, and then extend threshold 10, so just as a starting point for looking at the results. I don't want to export the results, so we delete this postscript, and that's it. So we can save this batch by clicking on File, Save Batch and Script, and now we can call this second level 2 sample t-test or something like this, right? And now we have the job file that we can load again for running other 2 sample t-tests. Now we can run this batch by clicking on the green arrow as usual. And now we get some results again, and you can see that these actually wouldn't survive any kind of correction. So whenever you see here inf under FWEC, then it means it doesn't survive any kind of cluster correction for family-wise error rate. So this would be uncorrected now at p less than 0.001. There we have some significant voxels. Let's assume this is our actual result. So we can look at this again by using overlays sections, then going to previous and to the top to our SPM folder, canonical single subject T1. So this is just an MNI brain. And so we have some probably spurious activation now in the thalamus and so on. All right, one final thing I want to show you is how to export these results. So this thresholded map, which you can then import into other programs, for example, for plotting nice pictures of the brain. So for this, once you've thresholded your map properly, you can go to Save Thresholded SPM and then put in a reasonable name, something like young versus old for famous versus unfamiliar. And this is thresholded at voxel level 001. And so I like to put in this information of thresholding as well. And now if you look into your current folder, then it has created this nifty image, which you can then simply import in other programs for a nice visualization. All right, and this is it with second level analysis. So thanks a lot for watching, and I will see you next time.